The problems that you learned how to work today illustrate the law of definite proportions. And some students find it easier to work these problems by actually using proportions instead of the recipe method that Dr. Wiles shows you in the textbook. So if you read through his example and you completely and totally understand what he did and you want to work the problems that way, that is perfectly fine. In fact, you can just shut off this video right now and you don't need to watch anymore if you don't want to. If that method was a little confusing to you, if you understand a little bit about proportions and you want to see the problem worked that way, I am now going to work example 2.1 using a proportion method in place of using the recipe method that he talks about. I found that some students understand it a little bit more easily than the other method. So let's look at example 2.1. A chemist uses 32 grams of carbon and 32 grams of oxygen to make 44 grams of a gas with some leftover carbon. If she wants to make 110 grams of the same gas and have no leftovers, how much carbon and oxygen should she use? So the first thing that I want to do is to list the information that I have so that I have it all laid out and I can see. So when I start, I have 32 grams of carbon, and I know that there are some leftovers because it told me that there were. I also know that I've used 32 grams of oxygen, and you'll notice that I'm using some abbreviations. I'm using C for carbon and O for oxygen. And I know that when I get finished, I end up with 44 grams of the gas. Notice that they gave me 3 significant figures in each one of those, so when you write the information down, you want to make sure you keep all of those significant figures. Okay, in order to figure out the information that I need to solve this problem, the first thing I've got to figure out is how much carbon that I actually use, and I'm using the principle of the law of mass conservation in order to do that. I know that whatever I started with, the same amount of mass has to be there at the end. So at the beginning, I had 32 grams of carbon and I had 32 grams of oxygen. And if I add those together, 32 plus 32 is 64 grams to start out with. I know that I had 44 grams of gas to finish with. And so if I subtract those two numbers, that's going to give me 20 grams that I had left over that wasn't used to make this gas. Well, the problem tells me that it was the carbon that was left over. So if I started with 32 and I had 20 grams left over, then 32 minus 20 is going to give me 12 grams of carbon that I actually used. Okay, so now I know exactly how much carbon and how much oxygen was made to make this 44 grams of gas. And if you notice, 12 plus 32 does indeed make 44. So what we are trying to find out now is if she wants to make 110 grams of the same gas, what proportions of these does she need to use so that she doesn't end up with any leftovers this time? So in order to do that, I'm going to take the proportion of the carbon to the gas and the oxygen to the gas, and I'm going to do that like this. In the original gas that she made, she took 12 grams of carbon, or ended up using 12 grams of carbon to make 44 grams of the gas. She wants to make 110 grams of the gas, and so how much carbon does she need? Now you'll notice when I set my proportion up, this side was the first gas that she made. This side is going to be the second gas that she's making. So in this one, I've got the carbon on the top and the gas on the bottom. On the right-hand side, it needs to be set up the same way with the carbon on the top and the gas on the bottom. And you'll remember when you have a situation that looks like this, you can cross multiply. So when you type this into your calculator, you're going to take 110 times 12 divided by 44. So 110 times 12 divided by 44, and when you solve that, you should end up with an answer of 30 grams of carbon. Notice that as far as significant figures go, I had 3 here, 3 here, 4 here, I'm multiplying and dividing, so I'm going to take the least number of significant figures, which is 3, and so I need to have 3 significant figures in my answer. So that's how much carbon I need. I'm going to do the same thing and figure out how much oxygen I'm going to need to make 110 grams of the gas. So I'll set it up the same way, only this time I'm going to put 32 grams of oxygen over 44 grams of the gas. And this time I want to make 110 grams of the gas, just like I did up here. So type it into your calculator as 32 times 110 divided by 44, and you will end up with 80 grams of oxygen, 3 significant figures again. Now, once you've done this, you want to go back and make sure that this answer makes sense, because if I take 30 grams of carbon and 80 grams of oxygen, if I add 30 plus 80, I'm going to end up with 110 grams of the gas, which is exactly what I should have ended up with. So my answer makes sense. If it doesn't come up to 110, you know you've made a mistake somewhere and you'll need to go back and fix that. So to the proper number of significant figures, this is your final answer. Okay, now in the second part of the problem, he says that the same chemist does a different experiment where she reacts 18 grams of carbon with 30 grams of oxygen to make 42 grams of a gas, and she has some leftover oxygen. So what we want to do is we want to figure out if this is the same gas that she made before. Well, in order to figure that out, I've got to start the same way by discovering how much carbon and how much oxygen she actually used. So in the second experiment, I'll draw a line down here to show that this is the second half of the problem. In the second half of the experiment, she used 18 grams of carbon and she used 30 grams of oxygen, only this time it was the oxygen that was left over. And she ended up with 42 grams of the gas. So that's the information that I'm given from the experiment. Again, same process that I did over here. At the beginning, she used 18 grams of carbon, 30 grams of oxygen, and so she had 48 grams to start with. Okay, she had 42 grams of gas at the end, and so then if I subtract those two things, I'm going to end up with 6 grams of leftovers. So here I have 6 grams of leftovers, and that's going to give me 24 grams of oxygen that she actually used. Okay, so now that I know that, I can figure out what the proportions were between the carbon and the oxygen here and the carbon and the oxygen over here. In the first example, I used 12 grams of carbon for 32 grams of oxygen. In the second example, I used 18 grams of carbon to 24 grams of oxygen. And so what I want to know is, are those proportions equal to each other or are they not? If the proportions are the same, then I'll know that it's the same gas. If the proportions are not the same, then she's made 2 different gases. So all I'm going to do is I'm going to divide these out. If you type into your calculator 12 divided by 32, you're going to end up with 0.375 as a ratio between the carbon and the oxygen. On this side, 18 divided by 24 is going to give you 0.750. Well, obviously 0.375 and 0.75 are not equal to one another, so these gases that she made are not the same. So when you have a problem like that, you want to make sure that you actually answer the question. The question was, are the gases the same? And so make sure that even once you've done all your calculations, you then go back and say, no, the gases are not the same as each other. Okay? So this uses the proportion method in order to solve these problems. And then when you're comparing whether gases are the same or not, you're going to compare the ratio of the components. Notice we're not using the total amount of the gas here, although I could have. But normally you're going to use the ratio of the components to each other and see if they are the same or not.